Good evening, everyone. Welcome to Skill Jogger once again. We are continuing the SQL. However, I'm not too satisfied with the last episode regarding joins on AdventureWorks database. So I asked ChatGPT to create a small database which has three tables, and here's departments, employees, and projects. And we will right now try to understand all the joins that are in SQL, the most common ones especially. So at first I would like to show what's inside these small tables. So I will take the first one as departments. I will copy that. It is from, and from. The second one is employees, and the third one is projects. So let's see them all. Three small tables, two of them have 3 rows, and one that has employees in it has 4 rows. So we are going to start from inner join. So I have the script on my second screen. I will rewrite it. So it is employee name and the department name from employees inner join departments D on department ID equal to department ID F5. Let's just have a look at these tables separately. So we have the employees table and the departments table. So once again, okay, so this one is inner join, which also works if I use only join. It is working on the common rows for each table. So if we are considering employee ID, we have 4 rows. Each of them have the name of the employee, department ID, manager ID, which one is actually null. And the second one has 3 rows. However, the second one, department IT, is considered 2 times in this table for Bob and Charlie. So department ID is from 1 to 3, and it is also from 1 to 3 in this table. So it covers directly. So the number of rows is still the same. And yeah, that's actually it. It shows the common. If there would be department ID some another name and would be with department ID 4, which is not existing in the departments table, then it would be not shown here. Moving forward to left join. Left join is an example on connecting with project name. We are still taking it from the employees E, then it is left join on projects P, and it's connected on employee ID as well as on the employee side. And this one is let's change it into projects. Okay, so right now we are using the left join. The first table is before the left join clause, so we are considering employees. employees has 4 rows, 4 different employees names, and then like the right table is the one behind the left join clause, which is project P. It has 3 rows, and we are connecting it on employee ID. So we have employee ID from 1 to 4, and in this example there is from only 2 and 4, so 1 and 3 is lacking, so that's why there are nulls for ID employee 1 and 3. But everything from our left table is visible here. However, if we would use right join here, now we are considering this table project as the first table and attaching data from employees to it. So we have 3 rows here, and the project, there are 3 project names because we are extracting this column. So we have 3 project names. 2 of them have assigned employees, so 2 and 4, which is Bob and David, and we have Bob and David, and recruitment ID is also here. However, there is no employee assigned, so it's null. And that's regarding the right join. So it's the opposite of left join. If I would take the left join and rearrange the tables, the order of them in the script, then I can change it the right join into left join just from taking employees here and projects here, and that's actually now left join of the thing I have done. So we are back to the first option, right? So yeah, next one is full outer join. So let's go with select e.employee name p project name from employees, full outer join projects p on employee ID equal to p employee ID. So we have projects employee, and this one is an outer join, so we are considering these 2 tables. One has 4 rows, second one has 3 rows, and okay, so at first we are taking everything from employees table, which is this one, so we have 4 different employees, and then we are attaching here everything from the second table. So if we had some lacking project names for certain employees, and also there is an project name that doesn't have an employee ID, but we are using the outer join, so information from both tables that we are joining is now visible in the outcome table. Now moving to cross join, employee name, department name, so let's change it a little. Department name from employees E. Now it's interesting because in cross join I don't have to set on which columns it will be used, because it will just connect each row of one table with each row from the second table. Is there something wrong? Oh no, maybe. Oh no, not new query. Thank you. Let's just use this one. The employees Oh no, so I have employees, and maybe it was right, not sure right now. Okay, so the outcome table has 12 rows. It works like it's taken each row from the first table and applied it to the first row of the second table. So it's done four times, each name connected with one department, and after that the sequence started again. So again, each name with the second department. So that's how the cross join works. And last but not least, it is a self join. So it's connecting a table with itself, and that's why we are taking the employee name as employee. Now employee name as employee name as manager. This is from table employees E. However, we are using left join on employees M this time, and we are connecting it on E manager is equal to M employee M dot employee ID. Let's go. All right, so I have employees, and actually I need only this one. Okay, so what has been done here? So first we are taking the column employee name as employee. So this is employee name column. Second one, we are taking m dot employee name as manager. So we are actually taking the same column, but this time it has the manager name in the title of the column. It is extracted from the table employees, and after that it's connecting on left join and now E manager ID. So from this table, actually wouldn't matter if I would go with M here and E here. Have to check that. Okay. Yeah, so the order is is crucial for this matter, because now I have twice employee in Alice, and that's not what I want. So it has to be like this. Let's execute. So we are left joining employees M, which is with the manager. However, in the manager table we are using, okay, so I think I understand that for employee table, for this one, which is as employee, we need to use the foreign key from another table, which is manager ID, and as well in this one, which is actually this table with manager ID, to use a foreign key from the employee ID. And this is the outcome. So in one table there were employees with employee IDs. However, each employee is also a manager itself. I mean, each manager is an employee, so some of the employees are managers, and Alice doesn't have any manager. However, Bob and Charlie have manager with ID 1, which is employee ID of Alice, as well as David has the manager with ID 2, which is connected to Bob, and this is here as well. So right, so Bob and Charlie has Alice as a manager, and David has Bob. So a self join is an option to use the information that is already in a table, and just use it to create some a new table actually, and that's actually all what I wanted to say. Now I have some words in Polish that I would like to translate. What I wanted to say. Yeah. A data set, yeah, I forget how is data set. That's so obvious. Okay, so I think that will be all for now. That was some additional information regarding the joins. Could just recreate it on a smaller data set. Well, AdventureWorks is it has a lot of tables, so it can it can just be hard. I don't even have a word in Polish. Oh, I have a word in Polish. How is it in English? It can overwhelm a person like me to try, but yeah, it's skill jogging, so you can't discourage yourself. You can't think that something is too hard. If there will be enough tries and repetitions, it will get easier. I'm sure of that. So let's just keep jogging and see you soon, guys, with the next episode. So bye for now.